Hello? Testing? Testing? What's up? What's up, nerds? Alright. So, let me tweet that I'm live. Okay. Okay. You can't stay. Why can't you stay? Oh, okay. So, what do I need? I need a couple things open here. I need to look for the commands. Oh, still waking up. It's rough. Here we go. Florida Strawberry Fest? What is that? That sounds really good. Do you get to like pick strawberries or eat strawberries? How does that work? Oh yeah, we got all that HCI stuff done. Yeah, we fixed up my Bluetooth dumping tool, and then we were able to go to that one function. We can just XRF this actually. We'll pull this over here. This function here, the lookup command dispatch, we can see like it gets the OGF and it looks it up in this table to see if there's a pointer to another table, and then we go here for the vendor specific ones, and the opcode we're using is opcode 10, and this lines up with the different memory areas we can dump. So we have to start reversing out what these parameters are, but once we figure out what the parameters being passed in are, we'll hopefully be able to just I'm guessing it's just going to be a pointer to a buffer and a length. Like this one right here, this param, this is reading a byte here, I'm guessing, LDRB. So we could type this over to a byte probably on this field. Yep. So this, if we just look at this structure, I think this structure will hold up and it will look, it'll probably look very similar to this. Actually we want this one in this case. So FCOA is the opcode we're using. So this is going to be kind of hard to display both. But this is the packet that we're sending, this super peak poke. And we don't even need this console because we're not doing any scripting. This is the command we're sending, the super peak poke. And if we look at this, we're switching field 3 to see if it's a 1, which will be this this blue RF peak. This will be the poke. 4 will be Bluetooth memory read. This will be memory poke. And here you can see it's taking this field 08 and it's assigning to this field 04. So I'm guessing field 04 is the packet, and let's see if that lines up. So if field 03 is the access type, how does that look in the actual packet layout? Also, I fixed the stream delay. It should be like 5 seconds now or something ish. Swap those. So the packet that we're sending raw over the serial port should be OA. We send an O1 OA FC 0504, and what I'm guessing is the O1 gets stripped off, and what this param2 is, this is a pointer to the OA FC. That means no, not quite. Huh. 0, 1, 2, 3. No. Wait, that is right. This points directly to the FCOA. Then 05 is skipped. Then we're grabbing the next thing after that. and field 04. So if I haven't made a non-auto defined structure yet. So what we should be able to do is, this is an A struct, so how do I change edit data typed? Okay, so let's call this a Bluetooth packet, or HCI command. I could call this HCI command, and it's for the HCI command at opcode. I'm just gonna call it that. And this, what we should be able to do is start banging these out. We should have a, how do we edit this? Oh, I think I have to delete this first. How is that deleting? Okay, that deletes in a different way than I expected. Let's close that. Edit data type. I want to turn this into a word. Cycle. Oh, there we go. Okay, sweet. So this one we will call the opcode. And in this case, this will be the super peak poke. So you have an opcode, we have a length, which is 1 byte. What is the cycle again? What's that hotkey? B. This is the length. This should be a no new data type in the cycle fits. This will be padding. Then here, oh, what is that padding? No, this is the actual, this is the access type. And then we have then it is variant. I wonder if we can do enums. Man, if we could do an enum that is associated with a field. What is this? Edit component field, not quite what I want. Yeah, the structure editor is really cool. I like this a lot. Access type. So I'm looking through kind of how this packet is laid out. How do you do enums? Where do you see that? I'm guessing I have to make structures if I want to do that. Here, apply edits and add an undefined byte. Move selected components up. Clear it. Send the type manager. Okay. So create a so this is like copy, create a new one. I wonder favorite. Oh, this is kind of cool. I'm guessing you can add more to favorites here. Let's just go through and do it for one type first. But we have the access type here. So after the opcode and the length, we have the access type. Then we should have, in our case, an ARM address. So this is going to be it won't let me change these. I think because I have to clear these first. Yeah. DDW is how they do double words, I guess. So this is an ARM memory address. And I think this is if we're writing. So present on reads and writes. This is for the PMU reg offset. This is present for memory writes on ARM-based chips. Oh, is the value that's going to be read or written, is that a 32-bit value? Interesting. Interesting. So this is the value 32. I do byte at a time. I might be halving my speed. We might give that a shot and see if we can get a 4x speed up in our dumps. Because I think today we might end up doing a couple more memory dumps than to get more information or maybe start poking things in. So I think this is correct now. Let's see if this works. So This looks good, and this is the HCI packet. And I'm guessing param3 is a length, and they probably don't check any fucking lengths. So in this case, we switch on the access type. If the access type is a type 4, oops. If it's a type 4, then that means that we're reading ARM memory. If it's a 5, then it means we're writing ARM memory. So in this case, we'll take local 18. Plus ARM memory address. Kind of confused at what this is doing here. This is that zeroed out? I don't think it is. We don't see this zeroed out in every path. So load byte. We're loading a word there. Local 18. That's kind of confusing. Then we take the ARM memory address, subtract off this, so we always make sure we align it. Wait, how does my stuff work? And then we AND FF. We take the ARM memory address, we subtract the ARM memory address and that. What? Is that what it's actually doing? I feel... Oh, yeah. We take HCI packet, this. Huh. We got a vuln? No, no, we just have a way to write into the chip. This is from the local side of things. But we're going to try and poke in our own custom command handler and see if that works. So I'm trying to figure out how this is... Like, this is what I expect. If the address AND3 is 0, if it's an aligned address, then we'll take the value 32 and we'll store it at the address. And this, I don't think matters. Oh, we write this out at the end. So this is kept around so it can write off that this happened. And in fact, it actually bytecasts it, it seems. Interesting. Interesting. So in this case, I just don't know why it's taking a reference to a local and then adding this to it. I'm confused what that is doing. Clearly it's dereffing the address that I give it. But I feel like this is a really, really extra way of handling this. And then that's stored into this, and that's returned out here. And it looks like it just reads maybe 1 byte there. You know the structure feature automatically recurses into children that can auto-update if you, when you set future pointers to that type. Ooh, I didn't know that. Gotta go? Alright, see you around. Okay, so in this case, I'm really confused what this code is doing here. We load byte based on local 18. Local 18. These are all breaks here. Param 1 is 12. So let's start to look at what the responses look like from these packets. Because once we see the response, then maybe we'll be able to see what it's filling in on the return side, and maybe figure out what the shape of this param1 structure is. I'm guessing this is the length here. It's probably the same shape as this, in fact. Let me look at what I expect back. And I think it's just I need to get rid of the prefix there, the O1 prefix. So when I send this super peak poke, I expect an event back, I expect a command complete, and then number of remaining bytes. That's not at offset 3. Opcode status. Number of command packets. Oh, maybe it's filling in. And then 12. What's 12? It's putting a 12 at the first location. Is that command complete? Or that might be a different one. 12 is probably one of these error codes. I'm guessing this is the output starting at, this is probably the status. So this is probably returning with the status code, or this like event type, packet type. Maybe this is the event type. On these ones, what do we put in here? We don't put in anything right at the start. We put in this at E, at offset E, which doesn't line up with us. It's possible that there's more to this structure and it's not directly outputting what we see on the wire. Let's find a different packet. So if I have my Wireshark window open, and that's the old firmware, so I'll close that one. Save. So if I pull up Wireshark, I think there was a command pretty early on that was very, very clear. Read local name, this one. So if we look at this one, sent packet command opcode, we just want the OGF and OCF. So in this case, we know this is an OGF 3. So if we go, let's name this function quick. This is handle super peak poke. Okay. So then we can go up and we can start looking at, so these are all the different commands that this handles for the vendor specific. So this is, we'll rename this vendor specific OGF handlers. And if we look at xrefs to this, there should be just one, which is going to be in the OGF dispatch functions. And in this case, we are looking for command 3, so the third one, and then we're looking for, or the command, or the group is 3, the command, command is 14. So let's go up. Let's make this into an array. This should be 0, 35, 35, 6E. So this will be a hex 6E in length for this array. 6E. Yep. And now we have an array here, and this is OGF 3 handlers. And oh, this is host controller and baseband commands. OGF, host controller and baseband. Okay. Save. And then we go to 14, which I think is, what is that? I think this shows me in decimal. Yeah, it does. So if I went to this address, OX to this plus OX4 plus OX14, was it? Yeah, 14. And now I have a popwonder. Damn it. That did not put us at the right spot. 14, jeez. Let me do my Python conversion. OX14, that's 20. We're still waking up. So this should be the command handler. This will be for, what is this command? This is read local name. Read local name. And if we take a look here, it's going to take b param1 as an input. This data is the, this is probably going to be your vendor string right here. Oh, CI20, is that what we're expecting back? Response, not quite. Did we do that wrong? I feel like we got the wrong function. Hex 14, this is a packet 3, opcode 14, unless it's not 0 indexed. This one, what's this? CI20. This one. 1AFO. Huh. Not quite sure how... This doesn't seem to line up the same. UEFRAM1. Passing in this data. Oh, unless it's offsetting here. Maybe it's adding that F8 to it. Do we see... I guess we can xref the string for this 4330. 4330B1. So window strings, window define strings. 4330B1. I think this is the only one I see. Looks good. Let's look for xrefs to this. Find references to. And I see one as a parameter. Where is that? Is it this? No. It is at B1. Why is that not lining? Oh, here. So I think this is memcopy. This is a new database, so we've lost some of these fields, but this is definitely memcopy. Okay, so we got memcopy. We're copying that, so that's where it fills it in for the first time. Huh. So I guess in our dump that copy hasn't occurred yet. Okay, so we did find the right handler then. Whew, I was about to say. So we can go back to, what routine was it? I'm looking for xrefs on this. This one, read local name. So it does line up. This is gonna do the copy. Let's see kind of what this does. So this function is probably a helper for a different command. So this is C14. Is that what this code is? C14. Okay. So I think this is probably constructing a packet, and then is the F8 the length of the payload? This might be a really cool thing to xref. I think this is going to construct a packet of that size. So the response packet that I got was 252 bytes, which is FC. But that has, I think it includes 1, 2, 3, what is that? 1, 2, 1. I think this is the whole packet. How big is this? 254, which I think is F8. 254, no, that's FE. So this must be giving the length of this part, the 248. This is F8. So it's excluding that. So it's the raw payload. So this is like construct new HCI response. BB PARM1, I guess, is apparently the output. So this is going to be the opcode. Do they call these opcodes? They call it a command opcode. Yeah, okay, cool. And we got a popwonder opcode. So we'll call that command opcode. Then the next parameter, this one is a length. Let's double check. This is the length of the raw packet, or actually no, it's a pointer. Then that, and then the data. So this will be the, let's see, what is the hotkey for edit function signature? This is a byte pointer to a, I think this is probably the output. Maybe? Oh, it could just be, this might be sending it as well. We'll see. Output buffer, potentially, and then this is the length. Excluding header. And then finally, the last parameter, we don't know what it is, I don't think. Oh, that is a pointer to the, this is the data to send. Edit function signature. We'll put this as a byte pointer to data. We'll call it input buffer. And this is probably length of input buffer. We'll see. So we might be able to call this function if this does send it. So this might be a really helpful way of getting stuff working here. So we construct a new HCI command. We take the length excluding header plus 6. And I'm guessing this might be a malloc. Plus 2. What's parm1? This is E. This is putting an E at the start. What kind of access is this? Is this a byte store? Store byte. It stores an E, and then it stores this minus 2. Length minus 2. So what is an E? Okay, that's that. That's that right there. So this is the event code. Sweet. I think this is calling malloc here. Maybe not. Maybe not. That. This is like get output buffer for packet. This might be a malloc, but I don't think it necessarily is. I'm guessing they have a pool for packets here. This parm1 is the so this is the length, and then this one is allocate HCI response, and this one was this is a byte, and this is the event code, and I think this returns a value, doesn't it? Let's take a look. Compare event code, get output buffer for packet. We store okay. Does this not return? Maybe this just starts filling it in. Let's see. This might be construct HCI header. And that takes in get some output buffer for the packet. We take this if it's not equal to 0. Then we fill in the event code, and then we fill in the length minus 2, which will be 252. And what are we passing in? We're passing in a fixed size thing for this command. We're passing in that plus 6, which is this 1, 2, 3, 4, 5, 6. Okay. So this now includes the header. So we'll put a comment on this. Length now includes header when adding 6. Then we're filling in this output buffer, this var1. I think this returns. Is event code in R0? Yeah, it is. So this is, gotta edit the function signature, and this returns a byte pointer. So there we go. And that looks like that lines up better. And this is packet buffer. Looking good. Okay. So then that's going to fill in the length with this plus 6. So the size of the whole command minus 2. So this is 254, which is FE, and then it fills in FC. So it's constructing these 2 bytes here for the response, which is cool. And then we fill in this 5 at offset 5. So this is the HCI output buffer. Doop. And what is this doing? So this is at offset what? At offset 5. 0, 1, 2, 3, 4, 5. This is the status. Oh, is this passed in as 0? 1, 2, 3, 4, 5. Let's look at the color for this. This passes in the deref of this as a byte pointer. I think this might just be a byte, actually. This might be the status. So does that clean it up a bit? Yeah. Output buffer 5 is status. Then we fill in a 1 for this is number of command packets. So this is, let's retype this as, where's my structure editor? I might have that up on another screen. Let me grab that. How do I list all my structures? Classes? No. Data types. Here we go, super peak poke. So let's make a copy of that. Oh, new. There we go. We'll just open this in the editor, edit, and we'll make a copy of it. I think there was an option. Oh, this copy is a field. So I should be able to do this. Make a new structure. This is a HCI response. We'll call it HCI response header. Now we have a new structure. Oh, was that what I wanted? That is not what I wanted. Okay, HCI response header. This looks like this should start with an event code. So is this insert? Yeah. So this is a byte. It's called event code. We're gonna add another field, and that will be the parameter total length. Parameter total length, and then we have number of. Move that down. This editor is pretty sweet compared to IDA's. Oops. This is the this is number of commands, and so event code. Total parameter total length, number of commands. Then we have the opcode. Then we have a status. Be right back. 1 second. All right, sorry about that. I had a lot of phlegm in my throat. Okay. So we've got the status here. Then we have, that's it. I think event code, 1 byte. Another byte, total length, number of commands. Then we have opcode, which is a 2-byte word. Then we have status. And then we can get rid of these fields because they don't matter for us in this case. So this is the HCI response header. And I think we got that right. So I'm going to keep that open on another monitor. And sorry about the this low refresh rate. I'm seeing this as well. This computer is just ancient. It's like a 2 gigahertz first gen like Xeon. I'm gonna order one of the new like 990Ks that go up to like 5 gigahertz or something, which should give me the fastest single thread performance. So hopefully the stream will be the best quality. They'll probably come next week. So anyways, we will change this output buffer. Let's change this will return HCI response header. Oh, you gonna get on the maple cheats, dude? No. Oh, you're chilling? He's chilling. Okay, retype variable. We're almost there, dude. We see like where it's constructing the response packets. Yeah. It looks like actual fucking readable C. I wonder if there's a way to make this null. I think so. In this set equate. Let me save. I think you can like arbitrarily rename any scalar value or like any value to anything, even if it's just an immediate. I might be able to say this is null.
Nice.
Okay. Yeah, and that shows up over here too in the assembly, even though it's not null.
Yeah, because like I didn't even probably do that if you make like an enum.
Yeah.
And then you apply that to that.
So I wonder if I can maybe give this a type as well.
That's nice. You don't have to like make an enum for it.
Yeah. So this looks pretty much complete. I guess this is a... Is this a byte length? Does this one expect this as a byte as well? Parm1. This is like a really shitty allocator. I think this is a packet allocator for just specifically the packets. Is this a byte compare here? Compare load word. Okay. So that might be a word. Int length. I think that's fine. This is loading the it's just expecting. Okay. So then we fill it in here, we subtract 2, and everything lines up with our Wireshark that we're seeing. So this looks really good. So anywhere that does this, we now will know exactly what's happening. And this should now propagate up that type. Hopefully. Maybe not. Refresh. Okay, we might have to type this. Retype. This is now a HCI response header. And sweet, now it's filling in the status and the number of commands and the opcode. Then the input buffer will do the same thing over here. Oops. If that's 0, then we'll set this equate to a null, which is this. Boom. So it's really cool that you can just rename random things. What's this opcode? This is an FC something. FC4D. So I want to, like in this case, I want to make this a, whoops. This. Oh, that's doing it. It's taking FC and then it's subtracting 4D. So if the opcode is this, FC4D, let's see if we have that. FC4D. There's some like weird special case for this. We don't have documentation for this function. So I don't know what that does, but it looks like they probably have some like bug or something, or maybe this is a special handler for this. This is a mem set or a mem copy. Let's see what this is doing. It's taking this plus 1, the input buffer. If it's not equal to null, or the opcode is this. Oh, I see. So we're taking this path, and then what's this? I'm guessing this is probably putting the packet back in the list. Or is this transmitting it? This is doing... This looks like a... Is this just memcopy? HCI output buffer +1. We take the input buffer length excluding header. I think this is the length of input buffer. And didn't we already make a memcopy? But this looks very memcopy like. Parm4, I think that's incorrect. Is that just storing? Yeah, that's just R3, so that's incorrect. I'm pretty sure this is a memcopy as well. Maybe it's a stir copy and the other's a memcopy. This could be a stir-n copy. This might be stir-n copy. Let's see if there are null checks on this. So this would be the input. If it's a stir-n copy, this is the source. It derefs this. Trying to see if this is a stir copy. If while var7 is 0, that's for alignment. This is definitely a memcopy. So we'll take the man page for this and we'll just apply it to this. And then I think these pointers have to associate with their types. I had issues with this and the constants also. And I think, oops, continue editing. Maybe we don't have that. What size T? That one. Okay. So we now have that, which looks good. Memcopy to this buffer +1. Oh yeah, because it's adding the whole header. Ah, that makes sense. That's why it's +1. I thought that was a byte +1, but it's a header +1. So that's taking the whole header, which ends here, and it's writing out to here of the number of bytes you pass in, which in this case should be 248 bytes, which is F8. So when this is called, we should see an F8. Where is it? F8, there it is. And then this data is a pointer. Cool, so I think we have this function figured out entirely. And we just have to figure this out, but this is taking the output buffer. I bet this is transmitting it. So let's say maybe transmit HCI response. This is going to be a, what is this, HCI response? Do you want to order food, dude? What do you want? Doesn't know.
Haven't thought about it yet.
Hell yeah. Yeah, no worries. Then we're getting...
Can we do Thai or Asian or something?
Ooh, that would be good. That would be good. I'd do Thai food. I'm gonna do some Thai food. Okay, then... If response and 1, that's kind of weird. If it's unaligned, then we look at the opcode. I don't understand why it's looking at the alignment of a pointer. Otherwise, we call this. Oh, what? We get that. This is really strange. What is this doing? Move R4 response. Then we subtract 1 in that case. Okay, so this one we're just going 1 byte back. I see. So it's going 1 byte back, so it can probably fill in this byte, this 4. And then in this case, yeah, so then this is filling in. I'm pretty sure this looks weird because this is the HCI packet type. Is equal to, what is this packet type? HCI packet type 4 is an HCI event. And we can actually rename that constant, this one. And we should be able to equate this and call this HCI event. Yeah, that's so cool. And let's we'll change the equate to be all caps. Boom.
You want that ground beef caporal?
Hell yeah.
Alright.
Thanks.
Done.
Thank you. Good sire. Okay, so that has filled that in. Then at this point, I think we're now back one. I think that's why this is kind of screwy. Num commands that is equal to HCI event. Get the response code event. If it's not equal to 13, if it's less than 14, if it's equal to E or it's equal to F, then we go here. If it's equal to EF or equal to FF. So let's bring up that Bluetooth spec and find the event codes. This one. Hopefully we'll be able to find, let's bookmark this page. This is actually really helpful. Event codes. This is error codes. List of event codes. Where are those at? Possible events. Here we go. I'd love to just get a table. Oh, it's going to make me read. So I'm just going to look up what some of these constants are, if these are events. Because it's possible that this buffer has been shifted around and is no longer the same type. It might be looking 1 byte before. If you input more type info there might be less go-tos. Yeah. Oh, on some of these fields. So that, we have a byte. On this one, we have... What is this being used as? This is a long? I wonder if that's actually a long. I'm kind of skeptical. Ah, well, it uses it as a long. Okay. Oops. L. So, and then these guys. What is this? OX13. Oh, cool. Look at this. Is this lining up? Kind of. 13 through 16? Not quite. Never mind. Got baited. These are the responses. Possible events. Connection. Event code. Auth complete. Encryption change. Mode change. 1F. EF. It's hard to say if these are some different commands, and this is total parameter length plus 2, sending the response, which potentially is unmodified, and that sends this is probably transmit. This is probably sending it through serial. Let's see. I'm guessing this is going to transmit it. This is probably setting up the PUVAR. Okay. Let's name some of these fields. Complete static analysis or dynamic? What do you mean by that? Okay, I think this is probably like send serial message, maybe, or like send HCI response. And then this should be this is the size. Oh, we'll do this. I got a popwonder. Edit function signature, this is the size, this is size, and this is the buffer. And let's change this to a byte. I'm guessing byte is unsigned, I'm not sure though. Buffer. If the deref of the buffer is not equal to 13, if ivar is equal to this, if This is not equal to 0. This is maybe checking the, like, send state or something. This is going through, looking up some things, but that's not operating on any parameters. Oh, it is. Oh, maybe not. I think that's erroneous. So if this and 1 is not equal to 0, and this and deref buffer is not equal to 13, then this is malloc. This looks kind of malloc-y. Did we have a subtraction on one of these? Do you see any like -8s? This looks kind of like malloc, and then uvar4, is that something plus something? Oh, 10? That doesn't look malloc-y then. Let's see. Oh, do you do debugging? In this case, we can't debug this at all. We have no way of debugging this target. So this is completely static for now, but we're going to try to maybe get a GDB stub set up. So this is memcopying to puvar. So I'm guessing this is like get maybe like serial buffer or something. And then that's going to fill in the size. This is going to fill in some other field that we don't care about. Memcopy, and then it's going to take this, and we're going to call this, and get serial buffer 1000. This might be another memcopy here. I'm guessing this is doing the transmit, because these things aren't returning buffers. This is the last one, so one of these is transmit. So this might be, what is this function? What did this take for parameters? This took buffer and a size and this. 55455551. Trying to look if this looks like a response. I don't think so. This might be the actual transmit. I mean, both of these look sane. But this one happens all the time, so this one looks more transmit-y. Parm 2, that's not used. Local 24. We pass it to this function, which is this, which which goes here. Oh, there's no code defined here. BW that. var, then we end up calling this. We pass in local 24 and parm 3. I don't know. I'm pretty sure this is doing a serial write or something. It's kind of hard to say. This is going to here, and we'll just define some code here. Disassemble as thumb. Okay. And that's going to branch and link to here, which is, I expect we'll see some reads and writes to some like weird address, which will hopefully be mmio space, and then we'll call this serial write. Do you still look at this disassembly? Yeah, I do. Every once in a while, usually for like typing information, but I'm doing almost all my work in the decompiler. PCVAR1. What else? What else takes the length? I think this was the length. That's being put in a lot of places. It's possible that this just constructs a global, and it ends up using the global for everything. This might be the send routine here. If it's not equal to 0, return. I don't know. This looks like the most sendy thing. And I think this is looking up the send routine. This is going to do a bunch of stuff to look up some pointers in here. And I'm guessing this is to find the right send routine for the different packet types. So this is probably for a packet type 1, this is how it sends it, maybe. Writing to 360, if that, what's this? This, I'm looking for loops. This is enable interrupts. So this will be get interrupt state disable interrupts. Is it writing to constant hardware addresses? Yeah, it definitely is. Well, this whole address space is very fixed. So then this is putting in this, which is an O1A9F1BC. Ooh, this kind of looks like a response. O1A9? Oh, maybe not. Oh, that could be. So we have... So that's writing... I think this is probably filling in a ring buffer, and then that's getting put in a ring. I'm guessing this is inserting into a ring buffer, and that's going to get DMA'd off. It's probably a DMA-based serial port. It's probably not doing like PIO. I think we're pretty safe. So let's look at find uses of this header. I don't know where that went. Find uses of field. Oh, that's kind of cool. Find uses of. Oh, here we go. It popped over here. So, bunch of places. So this is construct HCI header. And then let's look at things that use this. Oops. Yes. Uh-oh. Hopefully we didn't break it. I hit a key on accident, and I'm curious if this is now gonna freeze up. Nope, it looks like we're good. We'll undo that. So if we go up to construct HCI header, and we care about things that call this, these are things that are going to be making packets, and we should have a bunch, and we do. So like here, that's a event FA, or is that the event code? Yeah, event code and length. So event code FF, event code EF, event code 3E. So cool, there are a bunch of things here. This is nice. So this is construct HCI header and then send HCI response. And this is taking buffer. Yeah. So send HCI response is the one we really care about. And this is only used in a couple places because I think it probably wraps function pointers for a lot of these. So it might not be sending the response manually. So this is maybe transmit HCI response. I think this is definitely it. Transmit HCI response. And this is used in a lot of places. So that's looking promising. So and this is taking a response. This is some random function, and this actually looks pretty clean. Transmit HCI response if param is not equal to that. We got a mem copy. Okay, so this is looking pretty good. Maybe you can look up the hardware spec. There's no hardware spec for this. It's all undocumented. Otherwise, I would be all up in that hardware spec. So transmit HCI response, construct the header, we get the response, we fill in number of commands, we fill in an opcode, number of command status, blah, blah, blah. So we could look at xrefs to this function, and this will probably tell us, oh, this is branch and linked from here and here. This looks like serial port configuration stuff. Yeah, so I think this is definitely, this is some data, this is some fixed thing. So this is constructing some fixed, yeah. We see this pattern a lot, this construct HCI header and then the transmit HCI response. So I think this is, does this allocate as well? Yeah. Construct, this is create HCI header for allocate HCI packet. I think that one will be good. I think that one makes a little bit more sense naming wise. So allocate HCI packet, we then transmit, and this is probably gonna relinquish it. The last thing this calls, send HCI response. Whatever the last one, this is probably putting it back on the free list, I'm guessing. So this will probably have a bunch of references to the list of things. I'm guessing this is free packet 2D. This is probably actually, this is like transmit serial DMA packet maybe. And this is probably a free HCI packet. Yeah. So that's probably transmit serial. This is probably free HCI. So and then if we look at the shape of usage of this function, we will see we allocate an HCI packet, we get a pointer back, and then this is the last place we use the pointer, which has to be where it gets freed. We go into transmit HCI response. This, what is this? This calls a bunch of stuff. This might be a free or something. Unless this is the free. This looks like some error path. Enable interrupts. Not quite sure what that is. But I'm pretty sure if bvar is not equal to that, if this, unless this is like, I don't know. This looks pretty correct. Then we have a mem copy of the buffer into this new thing that we then pass directly into this, and then we call a function on this with the buffer and size. And I bet this is probably the HCI packet pool. Yeah, they could have just forgotten to free. So let's see where else this is used. So now that we've named this HCI packet pool, this is probably a pool allocator. This might not be free HCI packet, it might just be free pool. So if we go up to allocate HCI, get output buffer for packets, is this close to the pool? Not quite. Kolb. Does that have any meaning? Is that a standard like allocator thing? But I think this is a pool allocator of some sort. uparm1. Oh, okay, now we're back in a similar looking function. I'm guessing this is like allocate maybe? Parm1. Parm1 in this case is this plus ivar2 times 30. So this is going through each offset here. So it's taking this address and it's adding 30 hex to it. Yeah, kolb. I wonder what this is. So xrefs kolb. Is that like a standard thing? I don't really care about reversing out the allocator, but this is definitely some sort of an allocator. If we look at xrefs to this, let's see if anything fills it in. No, it's just all things that ref it. Yeah. Get serial buffer. That passes in. These are definitely pools. It's probably a pretty straightforward pool allocator here. Okay. So now, let's see if we can figure out... we could start... I don't know if I can actually write to ROM. I think I have to write to scratch space. Or patch space or something. So what I want to do is look at the dispatch tables for the routine. So if we search for dispatch, the filtering is really slow, which is kind of annoying. This is a small database, but on like my MapleStory 3 or 4 meg database, this filter takes like 30 or 40 seconds, which is kind of annoying. But this is lookup command dispatch. Here's the dispatch. Here are all the different routines that we can do. So that's host controller. Let me find all the different events. So link control commands. I'm looking at the actual Bluetooth spec in this case. Command packet, event packet, data packets. So I think host controller. These are all events, I think. So if we look, this is stored at 2.8. Okay, so the vendor-specific OGF handlers are stored in, this is in RAM, so we can patch over these. So these, I think this is like an empty thunk. This is just like, this is like empty function thunk. Or empty unhandled HCI command thunk, we'll call it. So if we go into this, that does a memcopy there. So I think where these handlers are used, there's the people who call dispatch, the code that calls dispatch, probably will do the dispatch routine, and then this guy, if we look up at who calls this, I'm trying to see where this, oh, interesting, this is in another bank. So that's, okay, that might have just been a bad xref. Well, not a bad xref, but that's probably like allowing you to do some arbitrary command, lookup command, blah, blah. This one, I think, is the one I care about. So this is looking up the dispatch. It's calling it. Local 44 is, I'm guessing, so this is a pointer to a function. This is maybe getting the buffer, initializing a buffer or something. So I think for the vendor-specific ones, we can just start filling in the packet, and if it filled in a 1, that's probably the status code. It probably starts directly with the status code on those. Let's look at another one. Let's see if there are any that return a fixed string from our spec here. So let's try and find something that looks fun. Mute settings, loopback mode, data parameter, SEO stuff. Edit BD address. That's a standard command. I want specifically a vendor-specific command, because I think for the vendor-specific commands you just fill in the status and the response, and I think it just works. So let us try to call one of those invalid ones. So OGF dispatch functions. Let's go vendor specific, and then if we do, this should be FC00, FC01, FC02. So we'll send an FC02, and we think we should get a status back of 1 with no length. So I will do a, let's do a send HCI, send HCI packet, and self packet U8, and we'll grab request. Let's see, HCI, send HCI packet, and then we'll have this automatically give the response. So we'll construct a request. The request will start with this. We'll do an opcode U16. And that will be in, oh, they use Little Endian? Huh, that's kind of interesting. So request dot, man, my buffering is really bad. Pushing an O1, then request dot extend from slice opcode dot to LE bytes. So we'll send that. So that puts the opcode in place, and then the length of the packet. Request.push packet.len as U8, and we'll just assert packet.len is less than or equal to U8 max. HCI packet to long. So if the packet length is less than or equal to that, then we'll push that. We'll push the opcode, then we'll push the length, and I think that's it. I think we can just send. And then in theory, we could fix up these other functions to use this wrapper instead. But we'll just do this, and now we can do self.read event is the response. So that will send the packet with a given opcode and get the response. So now at the end, replay, we're not doing the probe, and we're just gonna play around with this. We'll do print O2x of bt.send HCI command. Was that what we named that function? Send HCI packet, close. And then here's the packet, or we send the opcode, which we want FC02, and we can send it a 0-byte thing. And what we expect to see here is oops, 193. We don't have standard. This is core. So we expect to see back. So that is the initialization stuff, and then we see a 4E4 1 to FC. So this is a response to F2. Let's fucking parse this. This will be a struct HCI event response, I think. A 4. Let me look at Wireshark quick. A 4 is an HCI event. Yeah. Okay, so this will be an HCI event. This should have, I'm just looking at Wireshark. This is the packet type, and this will be a HCI event. So HCI packet type here. Oops, packet type. HCI packet type, derive debug. And we'll do that down here for the event type as well. Event type. Event code in E, command complete, good. So this will be HCI event type. And we'll call this a response. And then we have a total command length. So this is the number of remaining bytes after this point. So parameter length, usize. Technically it's a U8. Then we have a next is the num commands, which is another U8. Then we have a command opcode, which is a U16. And then we have a status. And then payload. This will be the vector of U8s. Okay. So now what we'll do is impl HCI event response, fn parse, response, U8. Actually, we'll call this packet. And this is going to return a self. What we'll do is if we'll do match packet 0. And then I'm just going to split the window quick so I can reference that. And this font's readable for you guys. All right. Why is this not in tile mode? Okay, there we go. So I see. Yeah. Okay. So if we do match packet 0, then if this is equal to HCI packet, or if it's 1, then it's HCI packet type command 1, 2, oops. 2, 3, 4. This is an ACL, this is an SCL, and this is an event. Panic unhandled packet type X. And this is packet 0. And we'll do let mute response is equal to HCI event response. Whoa. Oh, I can't do defaults for those, so we'll just do this. Type, oops, packet type is equal to that. Let event type is equal to match packet 1, which will be these different things, so 3. I really wish there was a better way to do this, this code shape in Rust. 1, 2, 1, 2, 3, 4. Because I do this a lot, where you're destructuring an enum. Actually, is try into? Can you do this with try into? Whoops. This. Rust try into. I wonder if you can do try into on enums. Can you do this? Enums, because I know try into just got implemented. Oops. Rust try into. Why can't I find the docs for it? I guess it's technically the name of the trait is this. There we go, that one. This is in the nightly documentation. Try into. And I think, yeah, you want to use try from. I don't know if they have this on enums. That's for slices. Oh, try from you can use to convert slices now. You can convert slices into arrays now, I'm pretty sure. Which is pretty cool. That's helpful for parsing ints using the new like 2 BE bytes and stuff. I have to remember to do that. But that's pretty neat. So we'll just manually do this. Disconnect complete. Command complete. Hardware error. Num completed packets. I don't know what that is. Mood change. LE meta. Panic unhandled. Event type. X. Packet 1. We probably want a comma there. That's okay. So we have the command type and the packet type. Now we have let param length is equal to packet 2. This is num commands. Then we have opcode. Packet 4, 5, try into unwrap. Dot. Actually, I think we do this. U16 from LE bytes. So I think that works now, that try into is stable. Try into, we just have to pull in that traits. Use core convert try into, but that should be stable. Yep, and now we just have to finish it up. So that should work. That is really convenient now. I love that. So 4 to 5, this should be 4 to 6. Right, 3, 4, 5, 6, yep. And then let status is equal to packet 6, 2, 3, 4, 5, 6. And then the payload is equal to packet 7 dot dot into and HCI event response packet type event type param length num commands opcode status payload. And you might be wondering why I'm doing this, and it's because I'm gonna get some nice debug output. So now I can print, I think I can just continue to print that. Oh, that needs parse send HCI packet. And now instead of that, we'll do HCI event response parse this. 260 expected vec. Okay, yeah, this is now an HCI event response. Struct with a similar name exists. Response. So now, hopefully that will parse the response. Yep, we got an event, command complete, param length is 4, number of commands 1, the opcode is FCO2, the status is 1. And then the payload, technically we would want to truncate that payload down. Param length is 4, 1, 2, 3, 4. So let's do some extra checking on that. Oops. So here we'll do assert param length is greater than or equal to 4. This is not enough bytes for a header. And we're not worrying about the Rust side of things because the Rust side will panic on these. But what I want to be able to do is trim that payload down. This will be payload len is equal to param length minus 4, which is safe because we cast that down here. So now I can do payload is, actually we can do it here. We'll convert this to a usize. So if the perimeter length is greater than or equal to 4, then there's not enough bytes. Or if it's less than 4, then there's not enough bytes. Get the payload length, which is that minus 4. And then we should be able to do 7 plus payload len. And this way it will be strict and it will expect that we have at least that many bytes. So it will hard fault if it sent us back the wrong number of bytes. And then let's assert packet.len is equal to 7 plus payload len. HCI response was larger than expected. So this will let us blah blah blah. This will make sure that this will just be really strict and make sure that we got exactly the packet size we wanted, and then param length as U8 here. Oops. We'll actually go back to this model. We'll do this, and then payload len will be this minus 4 as usize. Okay. So command complete, yep, and all of our asserts passed, and we got an FCO2, and we have a status 1. Perfect. So if we were to look back at our code, we should see that, yeah, we got a status 1. So this, in the case of the vendor specifics, this parameter is pointing to not a response header, but close. This is just... Wait, how do they report the length? Huh. How do they know the length of it? Let me look at another one. Maybe there's another parameter and that function, this unhandled, probably just ignores it. This one takes an iparm1, which in an iparm2. So iparm1, this is definitely the output. We don't want to do that yet. And then iparm2. Let's go back to the one that we have implemented. What's going on? I've got a popwonder. Yep. So if we go back to one of these that we know, which is super peak poke, this is the output starting at status. Okay, yeah. So edit function signature. This is a byte. That's a HCI packet. This is a... I don't know what the param 3 and 4 are yet. Let's see if we can figure those out. Param 3, unused. Param 4. Is that actually a thing? Param 4, where's this code at? Where is, this is param 3. Where's param 4? I don't see param 4 here. Move param 4. Oh, that's strange. I wonder why that's not propagating. But edit function signature, yeah, I don't see that assignment of 12 anywhere in this, but that's fine. We'll edit the function signature. It definitely just doesn't take these args, I don't think. Output starting at status, HCI packet, and we still don't see that assignment of 12 to R3, do we? Hex 12 here, which is storing R3. Okay, so that looks like that's working now. So if we send a super peak poke, but with the access type of 0, we should be able to see opcode length, access type. I think that's the first byte. If we just send a first byte of 0, so if we do, this is an FCOA, right? FC. FCOA. We send an FCOA and we'll send it with a 1 byte, which is the access type. And then hopefully we see a response of 12 back, a status of 12. Failed to read all. Interesting. I don't know what that response is. Failed to read all. And then 3 is 1. Output starting at status. I don't know how it knows the length of the packet to send back. Like how does this return the length? Let's see. Move this 1. What's this? R0. Okay. I think this is a return value. This is an int, which is the size. Return 1. Huh. Is that just success versus failure? I don't think you're sending the payload. I should be here. Oh, maybe I have to send more bytes? Like, I'm definitely sending the FCOA. If access type, unless there's more, let's see, FCOA 05, 04. Oh, there's another length here. There's another length. We definitely send it and send an HCI packet. I guess I shouldn't speak too soon, but that worked for the FCO2. Like this one This one returns the response, but we can look. Send HCI packet, we construct the packet, and then we write it out to the serial port. And then we parse the response, which receives it. So, oh, interesting. Failed to read all. Oh, I'm not sending the byte array. Ah. Let me check. Yeah, that might be screwing it up. You are totally right. I'm so sorry about that. Thank you so much. We push the we push the opcode, we push the length of the packet, and then we extend the packet. Wow, thank you so much. That makes a lot of sense. Okay, so now this is the packet that we're sending directly, I think, at this point. So now we should be able to send like an XOO, and this should be valid. Oh, man. And yep, we got a response back, status 1. And now we should be able to send an FCOA, and I think it has a length first. And then this will be the type, and we should see a response of type 12. And it might cause us an assertion error. Status 12, yeah. So status 12, this one gave us, oh, interesting. We had status 12, and then we had 1 byte of response. I wonder if this is the length. Let me look at another one. So this one, I think should this one, I think should return 0. Store byte BXLR. Huh. 1 store byte to 0. I'm just not sure how it knows the length of the response here. So here it like does a mem copy and it loads this. It just does a mem copy and then it returns the pointer back. Unless it expects a pointer as the response? I don't know. So this one does a mem copy, and mem copy returns the base pointer. Yeah, how does this know how many bytes have been written or read? I'm really confused as to how that works. This one, blah, blah. Let's make this a function. Prim1, prim2. Unless it's always 1 byte, it's always, maybe it's always at least 1 byte, and the first byte is the length. Potentially, what do I parse for a response? There might be yet another length. Length of remaining bytes, number of command packets, opcode status, and then this is just the response byte. Huh. What's this one? This is FCOO. Let me see if I have docs for this. Where did that document go? FCOO. Oh, we don't have an FCOO. Let's see what other commands we have. Any reason why Guitar doesn't support standard C types? What do you mean? Okay, so write BD adder. This returns 1 byte back, but he is just calling memcopy and then returning the return value for, oh, well, I guess he's going to this. And this goes to here. And this goes to here. Oh, is this doing a send? Oh, you can use car. You can use unsigned car. I just do byte just because it's shorter. But yeah, the U long long. Yeah, actually, I'm not sure if. I think you can do unsigned long long. Huh. What other commands do we have? So this will be fcob, fcob. We don't have that one. So this is going to memcopy. That's going to set some data. That sets this. I don't know what that is. What else? This one. What's 13? Was that 13? 14. 14 in hex is OE. FCOE. I'm just trying to find a documented one of these. Maybe we'll go the other way. Oh, it's FC1E. I want one that returns a lot back. Yeah, so like this. FC1F. This will be 31. This should be function. And this returns back. This will return a status. And then LSB first and fill bits. So we should have 3 bytes coming back. And I'm curious, like, does HCI not allow nulls? Does it just do null checks on it? Like, does it do a strlen of the response? I feel like that's not right. You have to be able to return a null. Or it's possible that there's a fixed amount. So this is saying, I want to see. This one doesn't load R0 at all. All right, let's go up and look at who calls these. Find refs to this. We go up to this. We get the dispatch functions. We go up to this. And there are a couple different ways that we can get here. Those two. Okay, it's just this function. Then we return from this function, we return the pointer to that routine. And then this is probably another nop. Yeah, this is like yet another one. So we have this, which looks up command dispatch. It calls it with parm1, parm2. And then returns. So this function here. Okay, so this is like, this is a 163. What is 163 in hex? A3. FCA3. We don't have that, but it looks like FCA3 lets you just run like an arbitrary command through. That's kind of weird. It's like wrapped. Okay, so we're gonna call this run arbitrary HCI command, or process, or like wrapped HCI command. So we don't care about this. We care about this. There's only one other reference to look up command dispatch, which is at this location. Oh. 1 second, I got food here. Alright, my food came, but it didn't come with rice, so we're cooking some rice up. Alright, so we're looking at lookup command dispatch, which is used in this one spot, which returns this. This is the command to run. Then, let's actually change the return value of this. This should be returning a, is this the right syntax? I wonder if it's gonna take this. So, this is a, wait, this is the name. Is a pointer to a function which return, it takes in a byte output and a byte input. No! Wait. Board changes. I wonder how I do a function pointer. Maybe I just do a code star. Couldn't resolve type. Don't they use that in other places? Fuck, how do you do a function pointer? Edit function. This is the correct syntax, right? Like, that's the right function pointer syntax, isn't it? Is that it? Do I have to do that? No, I think it just doesn't like that syntax. Maybe if I make a type, dispatch func. Yeah, so it doesn't like that. That's fine. We'll make a new structure maybe. Missing the return value of it. Void star name void. Right? That is a function pointer to something that returns a void and takes in a void. Yeah. I mean, maybe it doesn't want name. I don't understand. That is the correct syntax for a function pointer, if I'm not mistaken. I just don't think it's happy with that. We tried it with and without names, so we'll just go with it for now. So this gets a function pointer. It then invokes it. This local 30 or local 44. This is the output buffer. Output HCI buffer starting at status. It's a big name, but whatever. And then this is the input HCI buffer. And that one, okay, so what is this shit doing? This is another pointer to this function, which does some stuff. So if it's an FC, oh, this is doing more dispatch stuff. So I'm guessing there's some generic handlers in there. So if this is equal to 0, or this succeeded. So basically, if there's no, this is some like generic command handler, or maybe not generic, this is some specific one. We pass it the same args, and then that returns if it's equal to 0. So if this returns a 0, then it's like unhandled. So this points to this, oops. This points to this function, and this function is like if this is getting the var1, this gets the OGF but not quite. So this is like vendor specific commands, so kind of OGF but not really because it technically needs to be shifted by more, and this is definitely this is the OCF. So if this is a vendor specific command, then we have a 14. Let me see if I have an FC14 handler. So it looks like they try to handle these if there's a hook. I have an FC1C. What about a 2B? Let's see. I've got an FC25. 5E. A2. E6. Yeah, I don't have the documentation for these. But this is clearly just invoking it in the same way. If it's OGF4, if it's not equal to 20, switch on OCF. So at this point it is equal to 20, which is some other special one. Then this, and these are returning, apparently this returns a value, this function. Let's see what happens if I make this return an int. If this returns an int, let's see if there is a return value. ivar1, which is 0. I think 0 means handled, and 1 means unhandled, maybe? Starts out as unhandled, and then it calls like this function, which is some very specific handler. If it's not equal to 0, then we go here and return 1. So I think this is like command handled. So I think returning 1 means that the command is handled, and returning 0 means it wasn't handled. But how does it get a length? Because if we go down here, that kind of lines up with this. So we're just going to call this another HCI command handler. If it's equal to 0, then if that is equal to 0, so basically if it wasn't handled by this command handler, then we look up the dispatch routine, and then we call that. And then this one probably needs to return... Shit, how do you set up a return value on this? Retype variable. Built-in types. Let's see if there's like a function pointer or something we can copy. Segmented code, address, generic clib. Where's there a function pointer in libc? Anyone know? See you later. So what function takes a function pointer? Like what libc function? pthread create. Pthread create takes a... do I have pthread? Pthread defines... signal. But do they type def it? Yeah, they do. Sig handler. Dope. That's what I want. libc start main. Okay, sig handler under T. This is... I mean, that's going to be wrong. But let's just see what happens when I do that. Sig handler T. I might have to apply the type here. Retype variable. Oh, it did. Okay, well, it doesn't like that. I'm guessing because it's not the right amount of args. So what was sig handler T? Sig handler T is this. And how do I like edit that or look at it? Type def sig handler T, void under sig handler T int. So it looks like you just do it as a function pointer entirely. So we'll do we'll make a new struct, our new data type. Oops. How do I make a new data type? New function definition? Signature? Ooh, interesting. That might work. I think this is standard call, or is it cdecal? I'm not sure. So we'll say this is a... Or do I want I think I want type def union function definition is what I want. I think you just might have to manually create it. We'll say this is a standard call, and we're doing, what is this? This will be command handler. Oops, that's the return, right? So it returns an int. It's called command handler. It takes a byte pointer to the input or output packet. We'll just say output and bytes times input. Okay, and then we'll go to this, and we'll change the type of this. This will now return a command handler pointer. I don't know if I need to do a command handler pointer or just, oh, so that, okay, interesting. So I think you might just need to manually create it. You might not be able to do function pointer syntax directly in it. So that's clearly right now. Perfect. And now we can go here, and how do I get this to clean up? I don't want that to be a sig handler anymore. This now needs to be a command handler pointer. Please clean up. Okay, that looks pretty good. Nice. So now it's going to take this. Does it care about the return value from this? It has to. Yeah, this is R0. Oh, did I not put a return value in this? No, I did. I'm kind of surprised that's not picking up the return value. We deref that, and then we call it. And what's the type on this? What? What? Command handler star, this. A pointer to a command handler. Retype. It doesn't like that. Maybe it implies a pointer. Fixed length data type required. Yup. Huh. Like I can't apply that type for some reason. Why would that be? Is this wrong? Retype function. Oops. Unless I just need to do that. Is that the issue? So now this is, no, that automatically makes it a pointer. That's kind of frustrating. Pointer to this. I don't know why it won't take that. No idea. What if I retype this one? If I give it multiple pointers? Okay. Oh, you know what? Maybe it's maybe this needs to be a pointer to a pointer. I don't think so. Word changes. Star star. Is that better? Retype. Now we can't make it that? What? So in this case, we can do that. And now it is typed, I think. No, what the shit? Is it not standard call? Is it cdecal or something? Is that the issue? What? Like, this is definitely just returning a function pointer. It's not a double pointer. Look up the command dispatch. Command to run. I don't know. So let's just, I guess we manually have to look at what the return value of this is. It's in R2. We get the return value. And then we clobber it. Oh. What? Oh, that looks it up, and then we blix at that, and then afterwards, after it's done, I guess it's not using the return result? It probably can't. Okay. I think it is applying the type, it's just there isn't a return value being used here. Unless it's used deep down. LDRB, command to run, compare with this. Nope, this is the return value from it. So this is the return value, and then this is going to probably construct a command here. Transmit HCI response. Opcode is equal to that. Output buffer starting at status is being passed in here. Num commands is equal to that. What? Allocate HCI packet. Opcode. This is the... I think this is off by 1. Command ID. If the return value is 1, then we send this. If its return value is 2, then do that. If it's not equal to 5, then we do that with the input. So I think 1 is when it's handled, and if it is handled, then we transmit this. And how does it know the length? This input, command handler, command ID, which is done up here. We get the input, we look this up. If it's equal to 4, if 2, starting at this, if bvar, I don't know if we're hitting that. I think we are. I think this probably initialize it with a fixed size. How does it know? Construct new parm1 plus e. This is the, what is it, length of the input buffer is here. So this is the input buffer length. This is the third thing in here. Another command handler. There's also this. Oh, I'm guessing this is probably doing that. Okay. Okay. I think this one might be doing the size first. Maybe not. Output buffer starting at status. This is where it is created, I think. Byte that. Is this just on the stack? Is this just a stack local here? Starting at status 0. Then we pass a reference to this. Let's make this a stack array. The return value. I think we're just gonna consume up these. Let's set these to a byte. Oops. Let's just do, can we retype that? Is that AU stack 54? I don't know what the type on this is. Let's see if I can do byte 26. Okay, so I think those were shorts. So we should be able to retype this to a byte of 26 plus 26 plus 1. Oh, let me do math. 53. Maybe 54. That might have been bad. Undo. Oh, I bet these bytes before are... Oh boy. This is really messed up now. I'm trying to undo it. Oops. Okay, so I think these are passing in to these functions stack 68, but I'm guessing it goes all the way back up to higher up on the stack. It's probably var 3. This is probably the start of the packet. And then if we add all these up, I don't know what that is. That's writing the opcode. This is writing some status maybe. I'm curious if this is the whole packet and this is just the offset. Let me see if I type this, retype this to a HCI response header. It can't be typed. Yeah. How do I wonder if there's a good editor for the locals. That's what I want. I wonder if there's a good way here. What's this? This is not happy. Invalid storage. So command to run. Input HCI buffer is a pointer. Then I'm guessing at this location here. Is there a stack editor? Edit function. Analyze stack. Edit stack frame. Ooh, yes. This is what I wanted. Okay, output HCI buffer. That's probably just going to go all the way down to here. Alright, HCI buffer. I don't know what the rest of this is. Input HCI buffer is a pointer, which I think was passed in. This guy gets it. Okay. This is probably like parse input buffer or something. So we've got this. We make an array, and this is how many bytes? Can we just clear those? Oh my god. Yeah. And then cycle bytes. Cycle clear. How many do we have selected? I don't know if the selection gives us anything. 44 and 19. Hex. 5D? Is that 5D? Or did I do that wrong? 2B. This is 2B bytes. Make this a byte. We're going to make this an array. Can we do make array on this? No. Create array. I'm guessing that's just going to go up to the maximum size allowed. Okay. Well, that was better than I thought. Now we've written that out. And input HCI, and this is, what's local 48? Local 44. Local, what's this one? Local 48, is that used anywhere? Local 48, not found. So that's unused. Return. Oh, which way is this going? I think it's this direction. I think this is right. This might also be in here, maybe. 2C, that would put it at 48 if we included that. If they just did hex 30 for the response. Let's see if there's a 30 anywhere in here. This guy. I'm looking for 30. Local 44. I'm just gonna see what happens if I do this. If I clear this, if I make this, we clear this, we make this a byte, we make this an array, we go to 48, which is the maximum size, and then we're gonna rename this to be the output HCI buffer. Boom. Let's see if this looks sane. 5.2. What is this syntax? Oh, that is, I'm guessing that's doing index 5 of a 2-byte element, maybe? And this is doing offset 8 of a 4-byte element. So this is offset 7. Output HCI buffer. I think we went too far. So this is saying it's giving, when we go down to this, command to run, we're now giving it output HCI buffer plus 4. And does that line up with what we want? Is this the response header, maybe? Edit. Response header. Where did that pop up? Up here. So this means we have 1, 2, 3, 4. This could be pointing to the parameter total length, maybe? 1, 2, 3, 4. Does it write at offset 3 in opcode? Output HCI buffer 5. At offset 4, it writes in a 0. That doesn't seem right. It's possible that it's not supposed to be offset by 4. I don't see anything accessing it early. Command to run. This plus 4. Where's the length? Unless the length is implied by the type of command. So we did this. We have the output buffer 5.2. Does this one take the, is this the opcode? Yeah. This is constructing the response. Transmit response. This is 1 byte into the header, I think. So instead of num commands, I think this is opcode? No. This is writing an undefined 2. This is definitely an opcode. Let's see how this is invoked. I think once we get this function, it'll be a lot more clear. We have, this is passing in a deref thing, and then it's also passing in the status. So I think this is status. And this one is opcode. This is a short. Oops. Okay. Then that's taking response opcode plus 1, casting it to a short. So I think we're off. This one is a slightly different one. So we'll make a new structure from this. We'll call it HCI response header skip 1. So now we can look at this. Oh, did that change this into a field? I want to expand this out. Duplicate component, duplicate multiple, unpackage. Oh, that's exactly what I wanted. That's pretty cool. So then this, we will call this. This one will be a skip 1. Rapon. We typoed. Response. Header skip 1. Then we change this to a skip 1. Oh, shit. Is it the other way? Oh, does it go back one? What is before that? It's go. I go back one. That's what it is. That's what it is. Crap. HCI response header. So there's an event code. I think this will now have. That's the event. Wait, what? What is this? Oh, I never modified this to actually skip one. Status is opcode. Shit. Maybe it is. I have to add some. Let's add a couple fields. So this will be one more byte. That looks right. Okay, this is definitely right. Are you deleting streaming videos? Nope. Part 1. Let me see if I can find it. I don't think it's unlisted. I think they automatically go up. Yeah, it's not unlisted. This is the part 1. Okay, so this now has another byte out front. So this is the event code. This is a byte. This is event, I think. And then I guess there's just one more thing out front. I don't know what they're putting out front. This is another byte, unknown. Let's see what they fill in here. So it doesn't fill in the unknown. So we get the, if we got a packet back, so this is the transmit packet. If we get a packet back, but this looks right. We set the total length to, oh, this is length. Sweet. Total length is length. Then we set num commands to that. So now we should be able to go up. And this is construct response. Construct response header and transmit. It's a long name, but I would rather have a descriptive name than a convenient name. So we'll go up to the xref to this. This might be used in a lot of places. It is. So, but this looks correct now. Parameter total length is that. Number of commands is 1. Opcode is this. So now when we go up, we will see that this is the length. So I guess the first byte is a length. So we are incorrect on our stack here. So let's clear that, and we'll make a new thing at 44. It's a byte, it's an array, it's at 44 elements. This is the output HCI buffer starting length. So it looks like there should be a length field first in here now. And I'm guessing so the first byte in there is going to be a length, and then it looks like it fills in the status code probably for you. Starting length. So this will fill it in. Now we can look at one of these dispatch routines here. Go into here. Go into here. So the undefined one will write in byte 1, which I think sets the length to 1. And then the status. Okay, now let's look at super peek poke. So this one sets in case 0. But how does this set a length? If the first byte is the length, so we're saying the first byte of that buffer is the length of the packet because we pass it to this, and we pass it the 0th thing. So if at 40 it's 1, this might be a structure. This might not be a raw output buffer. They might be wrapping this in something. So, this 40E. So that's definitely the length. This is the opcode. So let's make this into a structure. Did that work? We made an auto structure out of that. And oh, did we just make that into a pointer? Is that correct? Is this supposed to be a pointer maybe? We pass in this, and this might be the output thing, and the first byte, I'm thinking this might not be a serialized thing, because this has a length, and then it's followed by the opcode. Does that line up with this? Number of command packets? No. This does not line up. The fact that there's an opcode, and then there's a length and then the opcode, that doesn't match up with anything. Parse. Yeah, so we should have, oops, parse. We expect num commands then an opcode. And so this is different. This is some custom structure. So let's say, autofill in structure. We might have to change this. Let's see, let's clear this. Okay. Save. Now we have bstack68. Retype variable. Oh, we might have broke it. Hopefully we can undo. I don't know if we can undo in the stack editor and stuff. Oh, it looks like we can. Okay, we'll go back to when it was a byte array. Output HCI buffer. I think, is this one correct? This one passes it in and 5.2. 5.2, okay. And I don't think anything accesses at 0, so I think we can clear that, and at 44 we can make this. So now we're going back to kind of what we had before. Make this an array, 44 elements, save. And I think we're good. That looks better. So this is definitely not just a pointer of bytes. There's something more complex going on here. This is some sort of a return packet. So let's change this to some, we'll make a new structure. Let's add a field. So we'll make a new structure. Where did that go? Here. We're going to add a byte. We're going to make an array of 44 elements. And we're going to call this structure, this will be output response struct. This will be like command handler output. Okay, command handler output. This will then be, we'll change this edit component field. This is a, we're going to clear it. We're going to define this data type as this. Okay. This will be command handler output. Hopefully we can have the same name there. And this, now it's accessing these fields. Cool. So what I can do is hopefully destructure this on package component. Yep. And now that undoes, that unwraps the array. And this is now going to be a length. This is going to be an opcode. Clear this byte. This is opcode. Boop. All right, that's looking better. So this takes in an opcode and a length. That looks good. So then, someone asked a related question, but I can't find the time. If you open Bluetooth, can someone access your device? So that would depend on if there's a bug in the Bluetooth chipset or in the Bluetooth stack. I mean, we don't know. That would be Ode if there is. But given the quality of... I hope there aren't Broadcom people watching. I understand the struggle, but given the quality of Broadcom code, I would assume that if you have Bluetooth enabled, you will get popped. I mean, if you're targeted. But like, when we saw the Wi-Fi chipset, someone did some work on the Wi-Fi chipset and on the Android side of the Bluetooth stack, and they just found loads of bugs in both. I think PZ did the Wi-Fi chipset one, and they found like 3 or 4 RCEs. And this is just the Bluetooth side of the same chip, so they probably have similar bugs. Like, I don't know, but I would not use Bluetooth if you're really that worried about security, but a Bluetooth Ode, like, no one's gonna really have it unless they're looking. Yeah, there are bugs on Wi-Fi and Linux too. Yeah, it's like, just don't... If you're really that concerned, if you're concerned to the point that you think that someone's going to go after you with Ode, which basically means you're concerned about like a nation state, you probably shouldn't be doing work online. But I would say for an average user, it's really no concern. Use Bluetooth all you want. But assume that someone probably could get in if they really wanted to. If they could spend the millions of dollars to do the research to find a bug, then sure, they probably can get into your phone. But they can also get iOS remotes and Android remotes. Like, when you're concerned about nation states, you're fucked. So if your concern is nation state level threats, then you probably should have an offline network and do your research offline. It's just privacy and democracy not coming together. Well, laws prevent countries from doing this against their own citizens, at least we hope. So, but technically it's possible to get onto your phone. Legally, it is very unlikely that someone can get into your phone, but at that point, they're probably breaking a law or have a warrant or something. Nah, it's good. I think it's a good topic. Understanding your threat models is really important. So, and I'm just waiting on food. I'm struggling because I'm really hungry. I don't know if this rice is done. Let me check. Not yet. So, yeah, we ordered Thai food delivery, and we didn't get any. We ordered Thai food, and it didn't come with any rice. Will the VOD be available after? Yes, absolutely. So you should be able to go back in time on the live video, and further, it will automatically just be up at the same URL if I'm correct. The second I stop being live, it will just be here forever. So Field 03. Field 03, unknown, but is byte. So I'm actually going to have this structure, I think, up on another window. So we know that this is storing a byte, right? If I look at this code, they store byte. Yep. Actually, is that storing a byte? Yeah, because then there's a 4-4. So we clear, B, unknown, B word, boom. And then at 28, is this a D word? This is adding unknown D word. Then we're coming down here. Where do we fill that in? Store byte. we add to set the length, and 28 and 29 we set to those. And let me see if I can show numbers as hex. Oh, that's cool. There's an option to show numbers as hex here. That's pretty nice. So if we go to offset 29, this is some byte, unknown byte 2. Unknown byte 2. Oh, that's oh, you can only go back 2 hours. Yeah, you can only go back 2 hours, I think, on the live video, but once the VOD is up, I think you can go back infinitely. Let me check other videos, actually. Let me see. Yeah, like I have a 6-hour video on here. So they definitely have they definitely record the whole thing. So cool. That works. Unknown byte 2, field 28, that's also a byte. Unknown byte 3, save. And I think once we get all of these things kind of named, so this is filling an opcode. It automatically fills in the opcode with your input HCI buffer, which is, I'm guessing, pointing to the opcode. This is getting the OGF. This is kind of OGF, but it's not exactly the OGF because the OGF technically should be shifted by more. If the OGF is 4, it's 1. Otherwise, this is 2. If that is 4, which is 1, because technically this needs to be shifted more. This is a compiler optimization, I'm guessing. 1 and 2. I think this unknown byte 3 is probably the 1, 2, or 5. I think this is the... I'm going to take a guess that this is probably the packet type. I think if it's 4, then it's packet type 1 command. Otherwise, it's a packet type 2, which is an ACL. No, that's not right. I'm not sure yet. Unknown byte 3, 1. Okay. Command handler. I think we filled in all the fields in this function. So now let's go into one of our command handlers. So look up OGF dispatch functions. Actually, let me filter this. Let me start using bookmarks. Let's see if I can, how easily I can bookmark. Bookmark, Control D. This is, Control D. We're gonna call this, oh, you can do categories, that's cool. Command parsing, and this is command handler invocation. And then, are bookmarks in here? How do I clear my filter? How do I stop filtering? What? Delete. Wait, what? I don't understand how I clear the filter. Unless I have to do some A? Is this a bug? Look. Is this window just broken? We might have broken this window. Symbol tree. Where's bookmarks? There's got to be a bookmarks window. Bookmarks. There we go. Wow, these are like all analysis things. Category. This. Filter. We care about command. Category. Command parsing. Okay. So we can now hop here. I think these bookmarks are going to be really useful. Command parsing. Then if we go to construct response and retransmit. Okay, so now we can go to the dispatch functions. Here, we'll go to vendor specific, we'll go to super peak poke, and we'll make another bookmark here, Control D. Oops, Control D. This is under the command parsing. Oops. Come on. Come on. Super peak poke. So we can now go here and here. Okay, those bookmarks are going to be helpful. All right. So now we know that this doesn't actually, this is not actually the output starting at status. This is now a command handler output pointer. Output. Boom. Let's see if that cleans up. That sets the length to 12 if you send it a 0. Unknown but is byte. This is also a byte here. The store byte. Yes. This is at offset E. The offset E, this is some byte. Unknown byte. Whatever. Let's see if that propagates. Yes. Okay. Unaffected 5. This is the result at 4. Or unknown byte 4. This is the read results. So when we read, like in this case where we do a 4, we do the read result and we get that local 18. I don't understand what this is doing. The address and FFFC. So this gets the 4-byte align thing. So we take the address and subtract. Is this to get the alignment? Then local 18. Is that an offset from the stack local? I don't think so. Local 18. Huh. That. Actually, what is the ordering of this? That defined the nearest thing. Read result. In this case, read result is that. Unknown byte 4. Unknown but is byte. I don't know what this is. This might be the status, maybe. Let's try. Let's see what happens when we do a super peak poke. So super peak poke. So we want boop 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 boop. That's reset. Send HCI. Read byte. 1 XOA X. Actually, we already have that. XO5, XO4, and then this is an address. So that's the address that we read. Running through, and this is saying we got a command complete, param length 5, but we don't see this set the length anywhere but here. So what if we do case 0? So in the 0 case, that is this. We'll send this instead. Let's see if we get a 12-byte response. No. Command complete, param length 5, number of commands, payload 0. I don't know if that's the length. This might be the length. But the other one... Oh... We might just need a bigger function here, so we can maybe learn a little bit more. I think this one always returns 1 byte for the payload. Read result, unknown but is byte, length 12. On the case 0, what is read result? That is that initialized to anything? I wonder if this is just uninitialized stack you get back when you send this command. I wouldn't be surprised. So let's go look at some other dispatch functions. Let's look at Don't know what this is. Let's try and find a big one. Ooh, this one's kind of interesting. Is it? No, not really. Unhandled super peak poke. So unhandled HCI command. I wonder if I can blanket apply these to be dispatch command handlers. Let's see. Function, data, comments. I'm gonna clear these. I might have to clear it here. Clear this. I'm going to make a pointer. Can I set the type? Choose data type. This is a command handler. I was hoping that would propagate that through. Command handler. This doesn't take out. This is a command handler output. And it's probably standard call. Go here. I was hoping that would affect the prototypes, but whatever. So then we have to go back to refs to this. Should be 1. We know there's D5 entries in this array. D5. Memcopy. I'm looking for something that uses the output. These are all setting globals. This one, param1. Nope, setting stuff. It doesn't even use the args. This one looks fun. This one doesn't look fun. Damn it. Param1, here we go. Here's one that sets some fields. Edit function signature. I wonder if I can just say command handler. Nope. Damn. I was hoping I could just, so this is, we don't know what command this is, but this is, okay. Abort. So this is command handler output. This is a byte star. This is the input. Okay. In 1 second, I'm going to check on rice. Rice isn't cooked yet. Okay, so this is saying output length is C. This one's good. I like this. Has a little bit more variance, and it's not using, it's kind of using input. It's setting this to input over here. Wait, what? This. Okay, so we can apparently set up this pointer. We might kill the device by doing this command. But that's the fun, you know? So we'll find the refs to this. It should be in, it's in 2 different dispatch tables. So this one is the vendor specific. We want 21. 21 in hex is 15. So let's send FC15 hex. And we'll send it no payload. So this is giving me back a 2-byte response. So where does it set 2? Where does it set a length of 2 here? Num commands, opcode, FC15. We're getting back param length, unless this is the length, maybe? This 5? So I don't think it's C. Unless this is the total. Wait, is that the total length? And let's see if this. Oh, we hard reset the device when we do this. C. How big is this response then? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Nope. 5. Param length 6. 1, 2, 3, 4, 5, 6. I wonder if this 5 is the length. Unknown byte 3. Let's go to super peak poke. And let's see if this one updates unknown byte 3. It doesn't. It sets length to 12. Whereas this one sets it to C. What? Unknown byte. So it sets a 1 to bud is byte, that is that. Output length is C. So if this is not equal to 0, otherwise we set this, and that's it. Alright, we gotta find a better function then. Param 2, param 1, not being used. Okay, nice. This is incorrect. Disassembly here, I think. Clear. This is a function. It should disassemble as thumb, and that's a function. That's good. And param 1. Okay, this one uses param 1 a little bit more. Construct HCI response. While. Do while. Huh. This sets 11. Construct new HCI response. That. Let's set the type of this. This is a command handler output. And param 1. This sets length to 11. This sets length to 12. This sets length to 0. Huh. I feel like I'd see bigger lengths. What? Maybe I can find. Let's find something in the Bluetooth spec. Link command controls. Link host controller and baseband commands. Reset, flush, read pin type. Read scan, read encryption mode. Host buffer size. Informational, here we go. Local version information. Return parameters. Status. HCI version, revision. LMP version, manufacturer name. This one looks good. Size 2 bytes. Oh, I see. I want like some strings. Read the country code, read the BD adder. Let's see a read BD adder. This one I think is 5. So this command dispatch. We go to then we go into here. I think this is the one, and then if we look at the 9th one, so make this an array of 9 elements. Yes. Oh, maybe that's 10. Actually, let me go back. I know the lengths based on where are they? This D5, so that's an A. Yep, 10. So this should be a 10 entry array. Yes. Oops. I just made an array of arrays. Pointer. Actually, we can undo. I forgot. We've got the power. All right. We go into here, and the 9th one. This is OCF 9. This should be get BD address, and that's my Bluetooth address. So this is your Mac address. And this is copying to iparm1, retype variable, blah, 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 blah. We might get there. This might be the one that gives us some knowledge. Command handler output star output, and this is read BD adder. Okay, so this sets this to 6. This must be the length, and this must be the buffer. So if we go to unknown but is byte, this is probably like payload length. Save, and then at offset unknown byte 4, this is an array. I'm just in the function editor, or the structure editor right now. We want to make this a byte. Let's make this an array of 26 elements. And let's see what happens. Okay, so we're gonna call this the output buffer. Save. Payload length we'll call this output buffer length. Save. Okay, so now those kind of line up. I don't know if we have those sizes correct on those structures, but we can make it work. So now instead of that, we'll send a this is a 5 shift, I think 10 or 9. Is this the right command to get the Bluetooth address? That's not right. FC, what's FC? Isn't it 8, 9, 10? Unless this is 4? What is the group on this? So we'll add this as a bookmark. We'll bookmark this as this. Okay, and we don't have to give it a description. Sweet, because it has the label in there. And then we'll get rid of this description here. Okay, so now we can go here, we can go here. Oh, the bookmarks are really nice. So, let's go to the lookup command dispatch. This is the, we'll bookmark this. This is OGF handler array. We'll make a bookmark of this. Save. Okay, so now we can go here, and we know that we want to do 4. Oh, well, we got it right with the 4, but this is 4, and then we go into 9, and then we end up using our read BD address, and this is OGF for OCF9. Okay. Why is no one reversing Mac stuff or Apple? I don't know. Maybe because it's riddled with bugs, so it's no fun. And it's all C++, so you're dealing with like object-oriented code. Okay, so this is saying output buffer 0 is read result, output buffer length is 1. Okay, so this is probably not a length then. What do we get back as a 12 here? So this one doesn't set. This is OGF vendor OCF OXOA. FCOA, right? Yeah. FCOA. Yep, super peak poke. Sweet. Save. Okay, so now these command handlers are gonna be a lot easier to read. So edit function signature, this is the default signature for all of these. I don't think that's a length field anymore, but I'm not quite sure what it could be then. Unless this is like the total length, but whatever. Output buffer length. Looks good to me. Now, that means I think we probably have all the information we need to construct a response. We can make our own handler now, I think. So this will be kind of our template, this read BD adder. So here's what I'm going to do. Read BD adder is at this location. What I'm going to do is we're going to look at the, we're going to add a new vendor-specific command at this address. This is here. So this is like an unhandled command. This is going to be fco2. So we'll send an oxfco2. If we send an fco2, we should get, the response we get will be nothing. It will be command complete, status 1, because I don't think that succeeded. So now what I can do is we can bang in the address. So we're going to have to write some new code, but we'll do bt write mem, and we'll pick an address. In this case, we're going to take this address here. Oops, we'll just type it out. Fuck it. We'll do it live. This will be at 28AE54. We will write the address of this function, which is OX103AE plus 1. So 103AE, which is the base, and then we want plus 1 because it's an offset, and then we'll do, or because it's a thumb function, and then we'll do 2 LE bytes. And we don't have that routine, so we'll have to make that. This will be super poke. So down where we do, that's the parser. So now we're going to make a write byte routine. fn write byte self adder u32 byte u8. And then now we can use our new function, self.send HCI packet oxfcoa. We want to then send it an access type fco5. We send the length, length of the packet, which is that. Okay, so we send it a type. We're gonna send it an arm poke. Then this is gonna be the address. So actually, let mute buffer is vec new buffer.push 5 arm memory poke. And then we'll do buffer dot extend from slice adder dot to LE bytes. Can you explain why it's address plus 1? So when working with ARM, when you branch to a register or like a memory location, if you add plus 1, basically if the bottom bit is set for an if the bottom bit is set, then it is a thumb function you're jumping to. So the processor will switch into thumb mode, which will decode 2-byte instructions. It's just a different operating mode of the processor. If you jump to an address where the bottom bit is 0, where that's not plus 1, it will start decoding the instructions in legacy ARM mode. So this processor only handles thumb, so we have to make sure that we're running thumb functions. And in this case, it is already a thumb function. Since this T mode is 1, that means thumb mode. So now we'll send buffer. I think we just can do this. Actually on a poke, ARM memory address, PMU reg offset, value 8. Present for memory writes. Actually, this is saying I need to write a 4-byte value. So if we look at this, this is the write routine. It's going to mask your address with 3. Wait, if and 3 is 0. So if it's, this is going to be if the address, it'll execute code from address, correct. So the address +1, that the +1 gets masked off, and it actually executes at address, but the +1 goes into an internal register in the processor that tracks if it's in thumb mode or not. So if the address is 4-byte aligned, then we get the, we don't care about that. So this is what we're doing actually right here. This is where we're writing. So this will be write U32 val U32 and assert adder and 3 is equal to 0 can only write to aligned memory. Okay, so if the address and 3 is 0, then we do this. Then we push that we want to do a poke. Then we extend the address, then buffer.extend from slice of val.2 le bytes. And then we do an FCOA of that, and that's it. I don't think we really care about the response. So now we can go down here and do a .write U32 of this +1. We no longer need this because it's implied. So we're going to add a command handler for FCO2 that redirects to the get MAC address. So hopefully this will give us our MAC address. No, it did not. Let's make sure we wrote to the right address. We wrote to here. We wrote a, let me print the result of the write. Print. Oops, we'll do O2x question mark on let response is equal to this. Okay, so this is saying I got an AF back. What? Push 5. Write the address, write this. So we do an FCOA. We send the buffer. We should be coming in here. It should be getting 5 from the HCI packet. Let's see if we're doing this right. Super peak poke, edit data type. So this is, we should have an opcode and a length. Let's see, this is doing send HCI packet. Send HCI packet will push 1, it'll push the opcode, it'll push the length, it will then push the packet, or it extends the packet. Then here, the packet itself will be a 5 access type, followed by the ARM memory address, followed by the value. And we send that. What's this response we're getting? This is saying an FCOA status 0. Is that what we want? Status 0, FCOA, or FCOA status 0. Oh. Alright, I got my rice. Hell yeah. So, now, let's see if this is a... I'm getting a response back from that with an AF. Read result is this. Wait, in the 5 case, it is set to the bottom of what you're writing, right? So it sets the output buffer to the bottom byte of what you wrote, but it writes the whole D word. The word. We might maybe have to reset the device or something. So it's giving us back AF, which is correct. That is the bottom byte of what we're writing. We go to the memory address and we write it out. I think this should be writing it. I don't know why this command is not now being handled here. It's possible the FCO2 is handled somewhere else. Like maybe something else is causing it to error out. Or maybe we just do it in a loop or something. But we're definitely writing that memory in. Let's try a different offset. Maybe we'll try FC. Maybe there's a big bank of like unused ones. This one. 28B118. 28B118. We're gonna write the value there. And then instead of FCO2, this is now 179. So this is B3, FCB3. Maybe we need to reset it. Maybe it's a caching issue. Maybe there's another table that's blocking this because it's unused or something, but that would make no sense to me. Weird. Let me reset it. No dice. No dice. What if we put A's in here? You know? I think there's something limiting us from overwriting these. What if I do it on the FCOA? This one. 28AE74. Like, we know this dispatch gets hit. You know what? This memory might not be writable. This might be more ROM. It's possible that we might not be able to write to this memory, or it's just getting like dev nulled. Let's do FCOA again. So we're gonna write in 4 ones at the AE74. So we're gonna overwrite one that we know works and know is getting called. And that, I think, worked. No. Yeah, I'm guessing we can't write to this memory. Okay. Find refs to this. Let's see if any of these are in a different location in memory. I bet the function... Yeah, I think I know what's going to happen here. I bet if we go up from here, I bet blah, 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 blah. Where am I going? Going up on a Tuesday. I'm pretty sure that this one, this lookup command dispatch, or I guess we have this. I think this code, this will probably be in an address space that we can patch. I bet this is patchable here. 200? Yeah. 200.97C. This is probably where we can patch, and I bet we won't get a response here because it will get broken. Yep. Unhandled type F. I think that might be good. Let's see. Are we influencing it? I think we're killing the device. Yep, we're causing it to reset. Okay. So this memory is writable here. So I think what they do is they patch in this, and this is in the patch space, this E0 space. And this, I wonder if they have another lookup table in here. It would be really nice if they did, but they might just have custom handlers for all these. Nope, this command handled is this. So here are things they patched. So they made patches for these functions, which is kind of interesting. So OCF. Here's a switch statement. Oh, this might not be as easy as just adding a custom handler. We might have to add code. So we could, in theory, replace this function. And this is the... So this is patched command handlers. And then we'll put this. We're gonna go. This is command handler output. This is the output. Byte times input. Boom. So hopefully that cleans up. So these are custom patched command handlers. Here's the output. We're getting the opcode, and then we're calling these dispatch routines. So FC14 got patched, and it now does this instead. What about FC2B? Okay. FCE6. I'm trying to find the biggest function, and then we'll start overriding it. So we should be able to do, this should be FCE6. At FCE6, we, I think, can write into this memory here. FCE6. This is going to be our donor function. And then we're just going to replace this memory here. We'll do it at this E4A10. And I think this memory should be writable. E4A10. We'll write a 414 there, and we'll see if we get a failure on this. Yep. And if I got rid of this. That looks good. Alright, so we should have code execution now by writing in bytes here. And we can verify that by, in this case, we're gonna overwrite, we're gonna make our write, we're gonna make our write bytes routine. fn write bytes self adder u32 val u32 actually data u8. Then what we'll do is while, let's see, I think I have a read bytes. I have a dump range, replay, dump. Oh, that writes to a file. Okay, so read byte. Okay. So while the address, let's see, and then we'll have an offset. What's the best way to do this? For offset in 0.data.len. We'll just go 1 byte at a time. This will be slightly less efficient, but the patch is going to be so small that we don't care. So then what we'll do is self.read byte at adder plus offset. And let orig byte is equal to this. Actually, we need to handle if it's unaligned. So if it's unaligned, we need to read the bytes individually. So let adder is equal to adder plus offset. If adder and 3 is not equal to 0, then we have to read let mute bytes equals OU84 bytes 0 is equal to this. Let adder is equal to adder and 3. Adder equals adder and not 3. Align down the address. Then we're going to read at 0, 1, 2, 3. And then we'll do, actually, we'll just do this every time. Why not? Okay, so unaligned adder is equal to that. We'll take unaligned adder is equal to that, and then we'll do let off is equal to on, apparently can't type, unaligned adder and 3. So that's the offset. So then we read the original byte 0, 1, 2, 3, and then we will write the, we'll do bytes offs is equal to data offset. It's kind of gross, but we'll read the 3 original bytes at that location, and then we'll fix up the 1, and then we'll write in all 4 bytes. Self dot write U32 at adder, which is aligned. So we read the original, and then we patch in the 1 byte, and what is this? Val. This will be U32 from LE bytes. So I think that should work now. So what I should be able to do is at this location, now I can do write bytes. Now I can do E4A, OA, and now we can do unaligned data. 2, 3, 4. This should fail, which will be good. Or it will fail the build. These need to be unwrapped. Definitely could optimize this function, but I don't really care. As U32 plus offset. What? 284. Oh, whoops. Did the wrong one. And 297. The offset, this will be as U size. Now, this should fail. Yup, good. Good. Which now means we should be able to... Now we can write in code. So we can find BXLR. Let's just find a BXLR here. I might have to get an ARM assembler up and running. I guess, it's E4AOA. This is the function we patch. And we're gonna make a bookmark for this. Command parsing, OGF vendor, OCF, OXE6. So this is the function that we're gonna patch here, and we just need to get an ARM assembler now. So let's do, we need another terminal. Where can I put this? Whoops. Start term and exit. Alright, we have a new terminal. And we'll make shell code, see shell code, vim, make file. And let's see if I have a ARM assembler, ARM Linux. That looks good to me. We can do this. Make file, this. Unless we want to write it in Rust. I think we could. That might be a little tough. We'll do shellcode.o, shellcode.s, sb, okay. So not make, okay. And then I just need to get the raw bin from it, which is copy raw bin. I'm just Googling it. I just forget the syntax. It's obj copy ARM Linux obj copy dash o binary shellcode.o shellcode.bin. Shellcode.bin should be 4 bytes. D shellcode.bin. Okay, and then we'll change this to also object dump. Disassemble all. I think we can do this. Oh, it's not gonna like that. I think we can just do it on the original O. I'll be fine. Okay. So L32 little arm, and we have an op. Perfect. And then in here, we can do let shellcode is equal to include bytes / shellcode.bin, and we'll just write that to here. And what's it complaining about here? No such file or directory / shellcode.bin. That is, we're in Bluetooth thumper. What did I typo? Oh, is that relative? I think that's relative to the source file. Yep. So now we've written in an op, so it still should fail. Perfect. And now we can put in a BXLR. We'll call this start BXLR. And now this should now succeed. Nope, nope, nope. BXLR. Why didn't I like that? what was the empty function? Here, here, here. Oh, I need to build it for thumb. What is that, I think I can do like .thumb2 something. Is that it? Nope. Thumb2. What is the trick? In the final assembly, so that's unified. Unified or divided. Thumb set. Oh, I can just do thumb maybe? I don't know if that'll be thumb2 or not, but I think it's fine. Awesome, it succeeded. Okay, so now what we can do is we know that the shape of the output structure here. We know the buffer length and the opcode. So I'm just going to we're just going to write into that structure. So we know R0, is it pound for comments? I think it is here. R0 points to output buffer. R1 points to input buffer. Then we have the what is this? What do we want? We want the shape of this structure, this command handler output. So we have how do you do structures? What is the trick? For structures, struct. Structure genius assembler. I don't know if I've ever done a structure. No, I've definitely had to have done a structure. That's not what I want. Structures and assembly code. Can I do struct? Dot struct foo. And is that the alignment? Oh, I could just do a label, I think. Here's how you do an example with gas. I use x86, struct 0, item start, item 1. So this is dot struct 0. We'll call this command handler output. And then this is going to be the length, which is a struct. What? I don't know if that's what I want. I think that's. Let's see. Surely. Why is it always so hard to find GNU assembler reference? Dot struct. Dot struct. This entire document doesn't mention structures at all. You serious? GNU assembler struct. How is that not a fucking thing? TASM GNU assembler also has a struct directive. Struct. Switch to an absolute section. Set the, okay. So I think we just do this, struct 0, and then dot struct length plus 1. God, that is disgusting. What a terrible way of doing structures. Okay. And then we have opcode dot struct opcode plus 2. Then we have Output buffer length dot struct output buffer length +1. So let's see if we can change that length on that. So we'll do a move R2. Actually, let's do. I think I want to push. We'll do push R2 LR pop R2 and PC. Man, I haven't written ARM assembly in so long. And we have to run make. Okay. Make. Did that generate no code? Where's my code? Make. Did this structure throw me off? What the fuck? Okay, so we save that. Now we can do a move R2 of, let's do just 16. Then a store of R2 into R0, offset by length. Actually, we'll do opcode. Store half, is it? Let me search. I gotta find our reference to that. Store LDRH. Yeah, I think it's store half. And let's see what this looks like. Yeah, it's immediate. Yep. OX 1237 and opcode. I think that might also need one. Nope. Prefix. Immediate expression requires that. Alright, fuck it. We're just writing directly to it. This is the opcode. What? Oh, yeah, you can't encode shit on ARM in thumb mode. Oops. Yep, that's still out of range. Let's just do 15. Invalid offset, value too big. We could do the wide version maybe. Unexpected kick. What is this syntax? That should work. And I should be able to do .w. Do I need unified? There we go. So that's better. Right? Yeah, that's thumb. Okay, now we can write to offset 1. We can write the, I think that fits now. Okay, so let's see what happens. Oof, that ARM assembly. Yeah, okay, so we got a response, opcode leap. There we go, so we are running code on this processor now. So what I should be able to do is, then we guessed that offset 3 is the opcode. This is the length of output buffer. Move R2, we'll move 16 into there. Actually, we can move like 128 into there. Store byte R2 into R02. So this is going to be the output buffer. Looks good. And now we should see, we should now see a response. Or a payload. And we don't. Huh. If I do this, this worked, right? It's possible I need to do a reset or something. to clear instruction caches. So that put in lead. Oh, we want to store, yeah, store byte. Store byte R2, which is 128. Oh, maybe that's they treat it as signed. Let's just do 16. Store byte into, oh, it's a different offset. My bad. This is 3. Okay, this will work. Guarantee it. And there we go. We got 16 bytes back. While I'm eating, sorry. Okay. So now, the output buffer is at R0. I don't think I need those in unified. Output buffer is at R0 offset hex E. So I should be able to put an A there. So I'll do move R2 OX41, store byte R2 to R0 OXE. And we should see the first byte will be an A. Now, looks good to me. There we go. So we now can run whatever code we want, and we can get the response back from this chip. Which kind of puts us in an environment where we can start making a better debugger or like a faster memory dumper. It also means we could potentially take a snapshot of the device from this function and then continue execution in QEMU, because we'd be able to dump all the register state in all the memory state. But I actually don't know what to do at this point. I like have, this was kind of my goal, is just to get code executing on here in a way that I understood. So, well, that's kind of fun. So I could make this a little bit better. We could change this to R3 as well. Add that as another clobber, and then we can do move R3 64, and we could do a loop sub dot is it S? Oh, you can't do the flag stuff in this. R3 by 1. Compare, we'll do compare R3 with 0, branch if not equal to loop. Then we can do this, and actually we'll go the other way. We'll start at 0 and we'll add that. If it's not equal to 64, then we go here, and then here we'll just do plus. Do we have to add that? I don't think you can do another, so we might need an R4. So move or add into R4 R0 plus R3. Yep, and then we always add E to that. So now we should get 64. Oh, if we hit make. So now we hopefully should get 64 4 1s back. Nope, I did my math wrong. Take R0, which is the output buffer. Take R3, which is our loop counter. If it's not equal to 64, then we go to loop, and eventually that gets to 64. R3 234 LR 234 PC. Branch not equal O. That is relative, isn't it? Branch not equal. Should be. It's not MIPS. Store 0. Get form 1 into R2. Store that byte to R4. Filled the read all. What if I drop this down to like 16? Oh yeah, there's a length limit on this buffer. I think it's only 26 bytes is the maximum I can do. So this should be 16.8. What if I got rid of this? Like, this should work. Oh, I didn't make it. God damn it. Should get 16.8s back. Yep. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now we're able to just run whatever code we want and get responses back, which means we can pretty easily make memcopy routines, even though we can already read and write memory in the we can already read and write memory inside of the with the routines we have, but this we'd be able to do a more accelerated one here by doing multiple bytes at a time. What else? But this is a good starting point for now adding random functionality you need to test your reverse engineering. So I think this was a pretty good result that shows that I found the right fields and I knew that they were the right things, because clearly I'm updating the right fields and it's working. So I think I'm just gonna call it a wrap there. I think that's I now have what I want to continue further and to start looking at the receive side of the Bluetooth controller, so I can start looking at bugs on inbound packets. And this will get me a good stub of now I can get arbitrary code running, so I can make things that can take snapshots of the device, and then I would be able to once I have a snapshot of the device, I could fuzz it in an emulator or something like that. So at this stage, it's pretty much, this is like kind of the end of reversing for me. When I get to this point, I can just bring it down into QEMU and I can start looking at it with the debugger, and life gets a lot easier. So I think I'm just gonna call it a wrap there, and that's it. I hope you guys enjoyed. Or I'll let you guys ask some questions if you have any questions before I go, and then I'm gonna head off. All right. Well, I'm not seeing any questions, so I'm just gonna call it there. So thanks for watching. Bye.